Wind turbines are devices that convert the wind's kinetic energy into electrical power. The result of over a millennium of windmill development and modern engineering, today's wind turbines are manufactured in a wide range of horizontal axis and vertical axis types. The smallest turbines are used for applications such as battery charging for auxiliary power. Slightly larger turbines can be used for making small contributions to a domestic power supply while selling unused power back to the utility supplier via the electrical grid. Arrays of large turbines, known as wind farms, have become an increasingly important source of renewable energy and are used in many countries as part of a strategy to reduce their reliance on fossil fuels. Wind turbine design is the process of defining the form and specifications of a wind turbine to extract energy from the wind. A wind turbine installation consists of the necessary systems needed to capture the wind's energy, point the turbine into the wind, convert mechanical rotation into electrical power, and other systems to start, stop, and control the turbine. In 1919, the German physicist Albert Betz showed that for a hypothetical ideal wind energy extraction machine, the fundamental laws of conservation of mass and energy allowed no more than 59% of the kinetic energy of the wind to be captured. This Betz limit can be approached in modern turbine designs, which may reach 70 to 80% of the theoretical Betz limit. The aerodynamics of a wind turbine are not straightforward. The airflow at the blades is not the same as the airflow far away from the turbine. The very nature of how energy is extracted from the air also causes air to be deflected by the turbine. This affects the objects or other turbines downstream, which is known as wake effect. Also, the aerodynamics of a wind turbine at the rotor surface exhibit phenomena that are rarely seen in other aerodynamic fields. The shape and dimensions of the blades of the wind turbine are determined by the aerodynamic performance required to efficiently extract energy from the wind, and by the strength required to resist the forces on the blade. In addition to the aerodynamic design of the blades, the design of a complete wind power system must also address the design of the installation's rotor hub, nacelle, tower structure, generator, controls, and foundation. Wind power or wind energy is mostly the use of wind turbines to generate electricity. Wind power is a popular, sustainable, renewable energy source that has a much smaller impact on the environment than burning fossil fuels. Historically, wind power has been used in sails, windmills and wind pumps, but today it is mostly used to generate electricity. Wind farms consist of many individual wind turbines, which are connected to the electric power transmission network. New onshore, on-land wind farms are cheaper than new coal or gas plants, but expansion of wind power is being hindered by fossil fuel subsidies. Onshore wind farms have a greater visual impact on the landscape than some other power stations. Small onshore wind farms can feed some energy into the grid or provide power to isolated off-grid locations. Offshore wind farms deliver more energy per installed capacity with less fluctuations and have less visual impact. Although there is less offshore wind power at present and construction and maintenance costs are higher, it is expanding. Offshore wind power currently has a share of about 10% of new installations. Wind power is variable renewable energy, so power management techniques are used to match supply and demand, such as wind hybrid power systems, hydroelectric power or other dispatchable power sources, excess capacity, geographically distributed turbines, exporting and importing power to neighboring areas, or grid storage. As the proportion of wind power in a region increases, the grid may need to be upgraded. Weather forecasting allows the electric power network to be readied for the predictable variations in production that occur. Wind power has been used as long as humans have put sails into the wind. King Hammurabi's Codex, Reign 1792-1750 B.C., already mentioned windmills for generating mechanical energy. The first windmill used for the production of electric power was built in Scotland in July 1887 by Professor James Blyth of Anderson's College, Glasgow, the precursor of Strathclyde University. Blyth's 10 meters (33 feet) high cloth-sailed wind turbine was installed in the garden of his holiday cottage at Marykirk in Kincardineshire, and was used to charge accumulators developed by the Frenchman Camille Alphonse Faure, to power the lighting in the cottage, thus making it the first house in the world to have its electric power supplied by wind power. Blyth offered the surplus electric power to the people of Marykirk for lighting the main street. However, they turned down the offer as they thought electric power was the work of the devil. Although he later built a wind turbine to supply emergency power to the local lunatic asylum, infirmary, and dispensary of Montrose, the invention never really caught on as the technology was not considered to be economically viable. Across the Atlantic, in Cleveland, Ohio, a larger and heavily engineered machine was designed and constructed in the winter of 1887-1888 by Charles F. Brush. This was built by his engineering company at his home and operated from 1886 until 1900. The Brush wind turbine had a rotor 17 meters in diameter and was mounted on an 18 meters tower. Although large by today's standards, the machine was only rated at 12 kilowatts. The connected dynamo was used either to charge a bank of batteries or to operate up to 100 incandescent light bulbs, 3 arc lamps, and various motors in Brush's laboratory. With the development of electric power, wind power found new applications in lighting buildings remote from centrally generated power. Throughout the 20th century, parallel paths developed small wind stations suitable for farms or residences. The 1973 oil crisis triggered the investigation in Denmark and the United States that led to larger utility-scale wind generators that could be connected to electric power grids for remote use of power. By 2008, the U.S. installed capacity had reached 25.4 gigawatts, and by 2012 the installed capacity was 60 gigawatts. Today, wind-powered generators operate in every size range between tiny stations for battery charging at isolated residences, up to gigawatt-sized offshore wind farms that provide electric power to national electrical networks. The environmental impact of electricity generation from wind power is minor when compared to that of fossil fuel power. Wind turbines have some of the lowest life cycle greenhouse gas emissions of energy sources. Far less greenhouse gas is emitted than for the average unit of electricity, so wind power helps limit climate change. Wind power consumes no fuel, and emits no local air pollution, unlike fossil fuel power sources. Onshore wind farms can have a significant visual impact. Due to a very low surface power density and spacing requirements, wind farms typically need to be spread over more land than other power stations. Their network of turbines, access roads, transmission lines, and substations can result in energy sprawl, although land between the turbines and roads can still be used for agriculture. They also need to be built away from urban areas, which can lead to industrialization of the countryside. Some wind farms are opposed for potentially spoiling protected scenic areas, archaeological landscapes, and heritage sites. A report by the Mountaineering Council of Scotland concluded that wind farms harm tourism in areas known for natural landscapes and panoramic views. Habitat loss and fragmentation are the greatest potential impacts on wildlife of onshore wind farms, but the worldwide ecological impact is minimal. Thousands of birds and bats, including rare species, have been killed by wind turbine blades, though wind turbines are responsible for far fewer bird deaths than fossil-fueled power stations. This can be mitigated with proper wildlife monitoring. Many wind turbine blades are made of fiberglass, and have a lifetime of 20 years. Blades are hollow. Some blades are crushed to reduce their volume and then landfilled. Blade end of life is complicated, and blades manufactured in the 2020s are more likely to be designed to be completely recyclable. Wind turbines also generate noise. At a distance of 300 meters, this may be around 45 decibels, which is slightly louder than a refrigerator. At 1.5 kilometers, they become inaudible. There are anecdotal reports of negative health effects on people who live very close to wind turbines. Peer-reviewed research has generally not supported these claims.